Now let's discuss about the torque which is experienced by a current loop in a uniform magnetic field. So this is the loop which has been given to you. The magnetic field is in this particular direction, that is I cap. You can say the current I has been represented here. The length is given as A, the breadth is given as B. Okay, so we need to calculate the torque onto this particular figure. So let us try to see now. So if we go and sit on the top, okay, we see the view from the top, basically from the top. First of all, I make sure that you know that this formula F is equal to BIL, okay, and the vector form also. So through that we will find out the direction of the forces. So if you find out the direction of the forces, you would see that the direction of the force onto this wire or onto this thing would come out into this particular direction. This is the magnetic field, and similarly onto this thing we'll get along this direction, and this is the magnetic field. Okay, so I hope that this is clear. The important part is to view from the top, so that will make it much more easy. If you view from the top, you would see just a projection of this thing, that is just a straight line from the top. So drawing that line is this. Now see, in this thing we'll get the force on the above direction, that is, let me say F UP, that is F up basically, and if we see that the force onto this point will be in the lower direction, let me say that is some F down. Okay, the magnetic field is in this particular direction, so let me label that also. This is some magnetic field B, which is a constant one. Now the dipole moment basically will be in which particular direction? That will be in this direction. Let me say any direction which is making an angle theta. We aren't sure, so let me say that makes some angle theta with the magnetic field. So let us try to take some projections. This length is equal to A, as you can see, which has been given to you. So this length is equal to A. Now let us take some projections here. This angle is theta, implies that this angle will also be equal to theta. So this length is equal to A sine theta. Okay, so I hope that this point is also clear. Now how does the torque come? First of all, let us try to understand that. I have told you, using the vector expression for this, you would see that the force on this upper thing is equal to, let me say, some F bar. Okay, so F vector. Similarly, the lower force will also be equal to F bar. So these are basically the same and in the opposite direction. So they will cancel out each other. Now the torque which is actually coming is due to the force which is applied onto this line and this line. It is just a loop which has been taken. No mass is present inside it. It is just a wire frame which has been taken. So now I can see from here that this side basically inwards has a force which is equal to BIL in this direction. Similarly, here also the force is equal to BIL. Thing to note from here is that these forces are the ones which cause it to rotate. So उसकी वजह से torque आ रहा है. There is no torque due to the upward forces because these are equal, but the torque is due to these forces which I have taken into consideration. Okay, so that is the only thing which I have represented here, that these are equal, so these cancel out each other. So वहाँ पर तो torque आएगा नहीं. Now we know that torque is equal to force into perpendicular distance. Okay, so that can be written as force कितना है BIL, perpendicular distance कितना है between the two sides, that is equal to A sine theta. Okay, so this is the value of the torque which actually comes into consideration here. Let me write it for you. In order to simplify this, you can also say that A and L, basically L is equal to B for this particular case. So A and B will form the area. So torque can also be written as BI into area into sine theta. Okay, so I hope that this point is also clear to you, but we need to evolve in the form of this dipole moment. So let us try to see that how we can use this part here. The torque is equal to this thing. If we had the dipole moment, what is the formula for the dipole moment? That you all know from the magnetic moment form, that M is equal to B into I. So M is equal to B into I.